Another thing that we may want to take a look at is the way the robot moves in between targets, right? So if I say, for example, move a large distance is up, so for example 400 millimeters, you can see that the robot moves linearly, right? So it moves exactly from this point to this point in a linear way, right? But as crazy as that may sound, for the robot, moving linearly is actually not great because it needs to like interpolate very weirdly between different joint rotations, between the angles of the robot, right? For the robot to go from here to here, it's actually much more comfortable to go like this than to go like this. This is a linear movement. This kind of movement, the movement where the joints, the axes are rotating freely, is called a joint movement. And we can switch between the two by saying motion mode. I open parentheses and I use double quotes because it's a word that I'm going to be using here, so I need to specify that it's a string. And here I use joint, I write joint, close double quotes, close parentheses, semicolon, and I hit enter. And as I do, you can see that nothing changes, but the type of motion that the robot will do next time it moves, it won't be linear. It will be a joint motion. So let's speed to 50 millimeters. And now let's move down a large amount, so 500 minus 500. And as you can see now, did you notice how the robot did this? Let's do that again. Move up, 0, 0, positive 500. Instead of going linearly, it's going to do like this, right? Because it just moved this one axle here. That for the robot is very nice to do, and it usually leads to much faster motion. But it also leads to motion that is kind of unpredictable, because for this one it's so simple, but if it's from one quadrant to the other, then where it goes through may not be easy to foresee. So unless you know what you're doing, sticking to linear motion is usually fine for the most part.